Guys, welcome back. I reconnected. Actually, it was popped off. I mean, Zoom was closed, and I reconnected once again. Welcome back to the second part of the session. And I'll just keep it open here, and let me thoroughly go back to my. Let's go back to this. Okay. Now, one last time, we'll try to do one thing. I just try to data. Is it two or one? Data one. So data two. One last time PD data frame, and this time I try to make it in a, I make this data set in a proper fashion using dictionary. That is how we create the data set. And if it don't work, then I'll just go straight away to my next concept. Gen is gender. Again, it's not going on. In instance, and here this is PD data frame. Not going on. So I'm even not able to create the data frame. So let me just delete this. Okay. Let me delete this. Okay. Now let me use this. Is it possible? No. I don't think. Sometimes I don't know what exactly is happening. You should be able to do. Leave it. Okay, fine. So I'm just going to leave this. And there is another ANOVA that is actually two-way. I leave it for you. You just go through documentation and I straight away go to the correlation. Now I explained you. Sorry, there are people waiting for. So we had discussion on descriptive analysis. I told you summary statistics and graphs, visuals, and then we had discussion on one sample t-test and two sample t-test. And after that, I explained you the correlation technique. Categorical data analysis. You have categorical data, then better to go for the correlation analysis. And then we had discussion on one way ANOVA, right? I have somewhere, I think in stats, you have a method called two-way ANOVA. Two-way ANOVA is there in somewhere in stats. You can just search for, wait for a minute. I'll just give you authenticated information. I think in stats, you have two-way ANOVA. Two-way ANOVA in Python. I'll just show you the example and thoroughly I'll just go ahead, take up the discussion for correlation in non-data science. And somewhere you should be having, yeah, here you see for two-way ANOVA you have, we are going to test the interaction. Suppose if you have two factors A and B, so that is why I'm sure even in one way we should have a factor-based data. In R we do. I still remember in R we used to do analysis in that way. N-way ANOVA. See, there isn't interaction, something like that. That is null hypothesis. Seaborn SNS things multi-comp. No, it is not seaborn. I think in stats itself you should have that two-way ANOVA. This is all complicated. ANOVA LM. Yeah, stats. You see, ANOVA linear model type 2. Yes, like this you have to do perform. You have the model, and on that model you will be performing. What is that model? OLS. I think OLS is not stats. OLS is no, not this one. I think. Wait, I'll show you. Today now in Python. I think we can go for stat, scipy stats documentation. There, I am sure you should be having a method for two ANOVA. Sci-fi strats. None. What happened? Yeah, this is actually the problem. You see, two ANOVA, you have factor A, factor B, and you have interaction A cross B, and we'll be doing SS between divided by SS within. That is SS total is SS between plus SS within. I think if you, I assume that all of you had gone through some fundamental, I mean, statistics classes. If you had gone through if you remember your statistics class, you can remember what I'm talking. I mean, you can understand what I'm talking. You can pick up what I'm talking. There are two masses, SS between, SS sum of squares between, sum of squares within. So finally, we have MSE means sum of MS, MSB, MSW, and MS means sum of MSS between, MSS within, MSSE, which means mean squared error, something like that. Uh, this is a manual approach. You see, these are all actually the manually. This is very important thing. It's always better to make calculations yourself, and this is stats. You got it here. Stats, something AOV. It's not like that. You have two ANOVA using stat models. It's not stat models. You can do better analysis even using stat models. In stat models, you'll get everything. I accept. It's a wonderful library. We are going to discuss stat models. We have those discussions ahead. Yeah, stat models, stats, and ANOVA. Okay. I think in stat models, you should be having a better way of doing as the variance. Okay, let us have some idea about the stat models. Theta square, omega square. These are all the measures. Now you want, I think, OLS formula. You want the formula. Yeah, like this. This is how you need to mention the. I mean, this is actually the model. You need to define the model for uh, analysis. You see here, left hand side you have a length, and right hand side you have factors, and here it is interaction. That is how we have. This is actually the protocol. Model, OLS formula, this formula, data. And what is that data? Data you should be having some. I don't know what is it. Let go through results. Hmm. Results. Yeah, here this is the data. Results. There is a dictionary, and this dictionary later converted into a results columns, column names, something like this. So you can just perform this. You can create a dictionary, and you can issue columns, and you can convert it into a table, which means a data frame. And you can this is what is the name of the AOV table one, right? Now go here OLS formula data. So AOV table ANOVA LM model is OLS formula data. Where is the data? Data is not there anywhere. We have only AOV table one, AOV table one. Okay, anyway, let's just go through this. I don't like to spend much more time on this topic because I'll be there here itself. So I have so many things to talk to you. Now let us go to the correlation. So if anybody of you, so there are three types of correlation. So there is no correlation, negative correlation, positive correlation, something like that. Okay. Okay, guys, let us go back to the, I think this one. Yeah, right. So let me close all these windows. Now, yeah, I think I opened this and I closed this. I'll be doing this type of manual activities. ANOVA. Yeah, you have F1 way. Yeah, F1 way is from stats only. And I think you don't have. And one more thing, you have a non-parametric equivalent ANOVA called Kruskal. Kruskal, Wallis, Gamma. So that is actually the non-pyramid. This is we have to perform gone. So my internet connection has gone now. Hello, are you all there?